Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan, from the Simple Electronics YouTube channel. This podcast is brought to you by listeners just like you. So go over to patreon.com/simpleelectronics if you want to contribute. Just a quick warning too, if this podcast sounds a little weird, for those of you who are listening to my live streams, you'll be aware that I am slowly but surely losing my voice. Usually this is caused by me teaching. So usually I have to raise my voice in order for a group of students to be able to hear me in a loud workshop environment. But for the last month or so, I've been losing my voice for no reason at all. And since healthcare is a bit in shambles in Canada, so I don't feel like spending an entire day waiting at a emergency walk-in clinic to get this diagnosed when it could be just nothing. I'm just leaving it be and sort of self-medicating with cough drops. But this podcast might sound a little bit weird as I cut around the problematic speech patterns. So let's see how well this goes. So to start off today, I want to talk about what I've been doing on the last couple of live streams. So you may have seen already that I posted my video for the Servo tester that is finally out. I'm really happy with how that project went. It uses the RP2040 microcontroller development board. I love it because it is all the power of a RP2040, but in a very small form factor and very affordable too. In fact, I just re-upped my orders. I just got 6 more and they were $3 Canadian a piece. So fairly good value for what you get. So the whole thing was that I made this thing and I coded it personally. You know, ChatGPT helped only in the sense of it helped me, with syntax from time to time. But essentially, it mimics the behavior of those little servo testers you can get on AliExpress or eBay for like $5-6. And it lets you center your servo horn or center your RC servo, I should say. So you can install your servo horn. And it also does the sweep. So it sweeps the servo, 90 degrees positive, 90 degrees negative. So you can check for any grit in the teeth or in the gears or any problems with your servo. And it also lets you control your servo manually. So I put all that together. I made a schematic. So people who only have an RP2040 in stock, but they don't want to do a PCB, they can just wire it all up onto a breadboard. I did that as an example, published everything on my website and published the video. And it seems to be fairly well received, which is really nice. I'm going to leave the link in the description to the website article and to that video if you want to check it out. I did follow my best practices, the things that I need. So I made myself a wiring diagram so that you can go onto my website and download the wiring diagram. It's very simple. So the diagram is very simple for you guys too. It's very visual, right? I used an RP2040 module, and then I did all the wiring sort of starting from those pins. I also did a table that showed you which pins do what, and I also provided the code. Now, I have the code on my GitHub, but I kind of hate when you go onto a website looking for an answer to something like that, and then it sends you to GitHub, when GitHub is not really beginner friendly. So with that in mind, I just put a giant block, like a code block on my website, and I just defaulted to saying, well, if you want the code, here it is. If you want the more updated code, you can check GitHub, but you can use the code here. You don't have to go to GitHub if you don't want to. You can just take the whole thing and then, copy and paste it into the IDE of choice and upload it. So those are, I'm trying to be the change I want to see in the world. And so that's what I did. So that article is live, and so is that video. I also finally got a chance to play with the big boy, the RP2350B. That is I think it's a 60-pin package. It's the big boy with the 48 GPIO Raspberry Pi chip. There are only 2 prototype boards, or development boards, I should say. where you can get them at the moment. One is the Solder Party version, which you can get on Electrons or Tindy, and the other one is the WeAct Studio board, the one that I use because it uses standard 0.1 inch headers. And these things are freaking monsters. And I decided that for the video, I would try to bog down the chip. I would try to use as many pins as possible and hopefully demonstrate how come these chips are such monsters. So what I did is I took all of the digital pins along the right-hand side. I think there was 15 of them. So along the right-hand side of the board, there are 15 digital pins and 8 analog inputs. But all 15 of those digital pins, I wrote code to randomly generate a number between 0 and 1 or 1 and 2, something like that. And it would correspond to a high or a low. And so every 100 milliseconds, the code would generate a random number 15 times and do a digital write to 15 digital pins and turn on or off the LED that's associated with it. Obviously, this wasn't going to bog it down. So then I also hooked up 8 potentiometers. So I have 8 analog inputs hooked up to each their individual potentiometers. And I made that do an analog write on 6 LEDs over on the left-hand side of the board, on the other side of the board. So what I did is I had 1, 2, 3 potentiometers were controlling the brightness, the PWM value of 1, 2, 3 LEDs. So you could use an RGB LED, for example, for this, but it turns out that the RGB LEDs I had here, they were common anode, not common cathode, so I didn't feel like dealing with that. So I just put regular LEDs in there. And then the fourth one in the series, so you got the 3 LEDs and then a fourth potentiometer, that would set the max brightness of the whole string of LEDs. So 3 LEDs individually brightness controlled, and then a fourth pot set the maximum brightness value for those. And so now every 100 milliseconds, or actually, I guess it does the digital read more often, but it would get, or the analog read, I should say, it would get the value of 8 potentiometers. It would map that value from a 10-bit value to an 8-bit value, and then it would output a digital or an analog write on 6 pins. And on top of that, I was like, I need to do more. So this thing has I2C. It has 2 channels actually of it, 2 channels of SPI and 2 channels of UART. So I decided I used one I2C channel because as far as I know, the overhead is a bit more on I2C. So I grabbed the I2C OLED and I had it print out the values of all 6 of the potentiometers. But that didn't even fill up the OLED. So on top of that, I had it generate 3 random numbers and display that on the OLED. And none of that affected the blinking speed of my LEDs. So essentially, everything was working perfectly, and I didn't manage to bog it down, even though, a lot of these commands have to be translated by the IDE into something that the chip will understand. So it's doing a lot more work than just what my code was. And on top of that, I think I used 0% of the program memory, and I used, I think it was 7% of the RAM. So even a large-ish project, a lot of things happening, it didn't even manage to come close to bogging it down. So on that video, which is not released yet, but will be released soon, I ask the audience, and I'm going to ask you guys the same thing. How do I bog down this microcontroller? Like, what kind of project can I make? What kind of coding can I throw at an RP2350B in order to try to bog it down? I'm looking for your suggestions in the comments, via email, via my contact form on my website, whatever you want. If you have an idea that might bog down the processing on this chip, then let me know because, I want to know. I don't know if you can mine Bitcoin or anything with them. I doubt that's what it's for. I doubt it's able to. But let me know if you have an idea that'll bog it right down. My thought right now is to control sort of like 2 TFT displays, for example. Like if you run 2 displays and you do some, UAG, some graphical library stuff, I think you might be able to get close. You might have it stutter a little bit, but I feel like that's almost cheating, right? Because modern devices, they have, discrete logic. They have circuits in them specifically to deal with graphics processing. And I think that's a little unfair to ask a microcontroller to do. I think something a little bit more fair would be like, I don't know, decode the Fibonacci sequence, like write out the Fibonacci sequence, up to like 1,000,000 places or something. So it might have a hard time doing that. Maybe. I'm not sure. But you let me know what you think I could do to bog this thing down. So far, I am very impressed. So look out for that video. I think I'm going to release it this weekend, but it is already live on Patreon if you really want to see it. Also, you can become a channel member if you just want to throw money at YouTube. You can do that as well. In the new projects category, a friend of mine from where I used to work asked me to make a F1 starting light for his kids. I guess his kids are into Lego at this time. They're quite young, and they built a couple of Lego F1 cars, and then they have them all displayed onto a shelf, and they just need a F1 start light in order to, finish the diorama, I guess. So I said, yeah, that's no problem. Like, I won't even charge you for this. Like, he's a good friend of mine, used to hang out a lot when we worked together. And I said, that's fine. I'll do it. So when I was on the live stream the other day, I decided to look up what it is. I think the main crux of it is just 5 red lights, or 5 pairs of red lights, horizontally distributed. So, there would be one on top of each other. That would be a pair. And then there'd be 5 of them wide. And when the sequence starts, the red lights, they light up one at a time with a 1-second delay between them. And then when they're all on, there's a 1 to 5 second delay, and then they turn off, signaling the start of the race. I think that's the gist of it. I had looked it up during the live stream, and I was like, fair enough. Yeah, you can just use 5 outputs on your Arduino, and then you just, turn them each on in sequence. Once it gets to the end of sequence, you can put a 1,000 millisecond delay, or you can do pause without delay, or what was it? Wait without delay? I don't remember. Where you don't even have to put a delay in. You can just count the millis, and then when 1,000 millis have passed, then you can go on to the next step. And then when it gets to the end, you generate a random number equal to the number of seconds going to turn off, and then it's going to turn off the red LEDs, and it's done. So I thought I could do this very quickly. But then when I was looking up what these lights really were, I realized that on top of these sequence of red lights, there were yellow lights. There's a row of yellow lights. And on top of that, there is a row of green lights. And so I asked ChatGPT what those lights do. And ChatGPT was telling me that the lights, well, they do all sorts of things. Like the green ones can flash, they can be solid. The yellow ones can flash, they can be solid. They can indicate, stuff about the races or whatever. The red ones can flash. And I was like, well, if we're going through all the trouble of making this light, it would be kind of cool if, the kids can go and click a button and then make the start sequence happen. That's fine. But what if you can also have it have static animation, like idle animation? So you can make the lights do stuff while it's just sitting on the shelf on. That's a much better decoration than just having the lights on at all times and you press the button and the start sequence happens. So I figured if we just add a couple more channels, like we add 1 channel for the yellow and 1 channel for the green, then in software, we can have it do all sorts of things. So this got my brain going. I put all the lights into sort of like a pattern, like I put LEDs on Vero board into a pattern to see what size we're working on. And I was like, okay, the RP2040 has enough room to sit behind here. And then I was like, okay, let's make a PCB for this instead of just, doing it all by hand. I might do the prototype by hand, but if I design a PCB, everything will be even neater. And then I can guarantee the LEDs are in the right spot. I can make a 3D printed housing. And so I was thinking that, I think what I want to do is have a button to trigger the start sequence, which is what the kids wanted probably in the first place. But now also I want a second button to be able to change the pattern. So it can do the start sequence whenever you press the start sequence button, but the other button will maybe make it cycle through a typical race. Like maybe it'll, do the start sequence and then it'll be green lights. And then at a random interval, maybe it'll have a hazard, then back to green, and then, red to signal the end of the race and cycle through that. Or maybe you can click the pattern button again, and then maybe you can get the flashing yellows, and then you press the button again, you get the flashing greens. I just thought it'd be really cool to make this project and then have a whole bunch of animations in software. And then this would make such a much nicer display piece than just having a press button and then it works, right? So this is what I've embarked into. I have the PCB almost half designed. I think I have all of the LEDs positioned. I have the RP2040 positioned. I have the pot positioned. I just need to run a couple more traces on the PCB, and then we're going to be good to go. But during that process, I also added a potentiometer. In fact, I wanted to add 3 potentiometers, 4 potentiometers, a little bit like I did with my RP2350B project, is I wanted to control individually the brightness of the red, the green, the yellow LEDs, and also have like another potentiometer to be like a global dim. But then the board got very crowded. And don't forget, this is the F1 start light sort of like hangs above the track. So it has to be small enough to sort of fit on top of where these RC cars, or Lego cars, I should say, sit. So here's what I did. I asked ChatGPT if it's possible to calibrate the brightness of the LEDs, like the PWM values, basically, of the LEDs, and save them in the flash memory. You get 16 megs of flash with the RP2040, which is a lot of flash memory, and it turns out you can. So ChatGPT gave me a piece of code, which I'm going to have to refine because I need to understand it for it to work, at least for me to be able to release it. But essentially, it looks to see if you press and hold one of the buttons for more than 2 seconds. And if you do that, then it enters calibration mode. And then you can turn that one potentiometer that I added to the board, and then that'll set the brightness of, let's say, red. So that'll be the max, or that'll be the PWM value for the red LEDs. Then you click that button one more time, and then you turn the potentiometer, and that'll set the brightness of yellow. And then you click again, and it saves that, and then you turn it one more time, and it'll set the brightness of green. And then you click it one more time, and it will save all those values to the EEPROM or to the system memory. I don't know where it saves it. It saves it. And then next time you turn on the project, those values will be saved, which is awesome. I didn't even know, I figured it should be able to do that because you have all this memory, but I didn't know how you could do that. And it seems like it is very possible. So I'm very excited to add some functionality and also learn something new that you can, save values in the chip's actual memory, which is very cool. And so anyways, what this is going to do is that means I'm going to be able to use resistors to set the brightness of the LEDs so that they're pretty close, but then go through and calibrate the red, yellow, and red and green LEDs to be the exact brightness that I want. But also, if it's the lighting in your room is much darker than what you expected, then you can put a screwdriver through the back of the housing that I'm going to design in 3D print and just twiddle the pot, and that'll give you that'll drop the maximum brightness overall so you can dim the whole project. I think this is super cool, the stuff that you can do with coding. And I've said it to pretty much all of the coders that I've had on this podcast as a guest, Like coders really are wizards. Like it's ridiculous that they can have the same hardware that I have in my hands, and they can come up with these kinds of solutions and code them, and you get really awesome products. But we started from the same microcontroller. So it's that kind of that sort of project scope that I wish to achieve by learning to code more and more. So here's my question to you guys. Those of you listening, what is the biggest, oh, I can do this moment that you've ever had while either coding, like my story, or just in your general making? Is there something that really startled you that you were like, wow, this can be achieved? If you have a good story, let us know in the comments below. A little bit of quick good news as well. Just before I started recording this podcast, I searched for Best Electronics Podcast. I sometimes do this in order to see, who is making what kind of stuff I should listen to, aspire to, etc. But one thing that I've noticed is that I am never on the list. The Simple Electronics Podcast is never on those lists. And, today, the first link I clicked was no exception. In fact, when I did this test last year, there was a top 10 best electronics podcast list, and there were only like 7 on the top 10 list. There was nothing else, and I wasn't even on there. But today, when I clicked the 15 best electronics podcast you must follow in 2025, posted on FeedSpot, I am number 7. I'm on the board, folks, in a very tiny niche that is, electronics podcasting. I managed to be named in, same company as Dave Jones. In fact, Dave Jones is number 6 on the list, and I'm number 7. Now, does that mean that Dave Jones's The Amp Hour podcast is only slightly better than this podcast? No, I actually don't think there's any sort of rhyme or reason to the list. I think literally there's not that many electronics podcasts. In fact, this top 15 podcast list only has 12 podcasts on it. I think they're kind of in no particular order. But in case you are wondering, according to this list, which I'm pretty sure is AI generated, by the way, number 1 is Embedded. Never heard of it. By the way, I don't consume very much electronics media these days. When I watch YouTube channels or listen to podcasts, it's mainly for entertainment. So number 1 is Embedded, then Electronic Podcasts EE Times, then Into Tomorrow, then the Geared Up Podcast, PCB Chat, The Amp Hour, and then yours truly. What an exciting day. Moving on, I thought we could use some of the podcast time to help people. And so I decided to go onto Reddit, reddit.com/r/AskElectronics, and sort by new and find some posts that had either no replies or very few replies, and try to help out some newbie entering the hobby. By the way, as people in the hobby or people interested with electronics, it is really incumbent on us to help newbies come into the hobby. The easier time that people have entering the hobby, the more the hobby will be able to grow. The more interest there'll be for electronic devices and components, the easier they're going to be to find, etc., etc. So I like to do this every once in a while. This one here has 13 comments, so it has more comments than I would typically answer for this segment of the podcast. However, I thought it was a really good question. So this is from EasyFrag 2016, and they say, can someone suggest a benchtop power supply capable of 60 volts and at least 5 amps? His description is, okay, I include this info to give you a laugh. I've recently started learning electronics, good on you, EasyFrag, and purchased a cheap benchtop power supply from Amazon capable of 60 volts and 5 amps. All was going well until I absent-mindedly connected it in reverse to a 48-volt LiFePO4 battery. It blew. I bought another one, and it all went well for a few weeks until I did the same thing, but this time with a 17.5-volt pack. It blew, but I was able to repair it enough to continue using it. So I've now spent $100 on cheap power supplies. My question is, would a better quote-unquote power supply have protected me from this type of stupidity, or would reversing polarity on a battery always blow a supply? Well, here in my lab, I've got two main power supplies that I use all the time. So the main power supplies I use are my read-in power supplies. I have a RD6018 and an RD6024. Those are the two main ones you'll see in my videos. But I also have a Unity UTP3305. I have the page open here. Yeah, here it is. UDP3305SE. Do I have the E variant? I think so. So I have, very capable supplies. They're not cheap, but they're not like super expensive either. So I went first onto Readin's website, which redirected me to an AliExpress page. So I don't think Readin has their own store. And I went onto the listing for my Readin power supplies, and they say they have quote unquote multiple protections. But every time I try to look into those protections, they're talking about electronic protections. They're talking about overcurrent, overpower, and overvoltage protections, which shuts down the output. That's not quite what we're talking about here. I'm wondering if it has protections against backfeeding from a battery. There's no information on if this would be a problem or not. The only thing I can see is on the back of the PCB of the actual buck converter section of it, there are two soldered fuses on the board. One of which I think is a 30 amp and the other one is, I'm not sure how many, but one is at the input terminals and one is just, on the board at large. So that means there are fuses that could blow and then you can replace them. But does that mean that it is protected against reverse polarity from a device like a battery? I mean, all the RD power supplies have a third terminal for charging batteries, but specifically it says on the listing that the battery charging functionality is only available for quote unquote professionals. If a non-professional uses it, then the device can be damaged. So that tells me that if you plug a battery with reverse polarity onto this power supply, you're going to blow it. Just like, this person, Easy Frag, would have blown his. So that didn't instill me with a lot of confidence. I mean, I have charged lithium batteries with that power supply, but I was just very careful to, set the polarity properly when I plugged it in. I tend to be careful because batteries, like I'm used to lead acid batteries, they have an enormous amount of energy and it can be all let loose in one shot. And on a car, for example, where I work professionally, if you if you plug the battery in backwards, well, you can blow a whole bunch of modules that cost you tens of thousands of dollars potentially. So, okay, this read-in one, it is not protected against reverse polarity. It doesn't seem like it, at least. If someone from read-in wants to reach out and talk about it, let me know. So let's go on to Unity. So Unity, on the specifications, they say there are a bunch of protections, but again, they list, over current, over power, over voltage, but nothing about sort of like, reverse polarity. So I went into the documentation, I went and got the owner's manual, and I can't find anything. I went Control F for protection, couldn't find one. I can see the over voltage, the over current, the over power, but I'm not seeing if there's, any sort of internal fusing in case you plug a battery in backwards. Then I checked the spec sheet, which is like the data sheet essentially. And again, it only lists one fuse, and that fuse is for the input on the back, 220 volt 4 amp. So here's the question. Is there any power supply that is protected from reverse polarity from a battery? Is there any power supply that if you plug a battery into them with reverse polarity that won't backfeed through the unit and blow it up? Is it possible to implement a diode protection like that? Because if I'm thinking about it, anytime you put a diode for reverse polarity in the path, that means that any current that you pull from the power supply will have to run through the diode and will eventually heat it up. So if you have, maximum current on your unit for a long time, that diode's going to get pretty hot. So I'm not really sure what the answer is here, except for make yourself some polarized connectors. So when you want to work on batteries, you need to figure out a standard connector that you're going to use, that you're going to connect to the battery. You're going to confirm the polarity with a multimeter, and then you're going to plug in the other side of the connector to your power supply, confirm the polarity with your multimeter, and then connect it. Because as far as I can tell, none of the affordable power supplies seem to have a reverse polarity protection. The other thing you can do is you can wire a diode in series with your connectors. So you can use, one set of charge leads that are just for charging that use a diode. But don't forget, if you're trying to charge, let's say, a battery, like a lithium battery, to its max voltage, to its max capacity, then you'll have to take into account the diode drop. So you'll never really reach the max voltage of your battery, because your power supply is always going to supply whatever that you punch into it minus the diode drop. Now, if you put in the diode drop on top of it, then you might be okay. But I'm not sure what happens when the current gets down really low. Will, the diode drop, and then you're going to be feeding a little bit more voltage into it, which can be dangerous for a lithium battery. Not 100% sure, but there's got to be some sort of solution. Let me know if you guys know of one. But I think I'm not going to comment on this Reddit post specifically because I don't have too much to add to the conversation. Next Reddit post we're going to reply to is by user Wangy Shang, who says, how do you pick a power supply for a buck boost converter like this, ZK4KX or similar? And they have a picture of just a very standard, very cheap AliExpress buck boost converter with a switch that controls the input-output and, a little knob to change the power. They write, I wanted to make a DIY lab bench power supply with my slightly used in dust collecting ATX power supply. My PC died 2 years ago, CPU and GPU failed. My extra 12 volt 5 amp switching power supply from the school project, the LM317 switching power supply I found on YouTube, or my chunky 65 watt PD 3.0 that makes my phone screen jitter when I use my phone. We'll be using for checking electronics components, salvaged or new, such as LEDs, fans, and motors. They continue. I don't know if a 12 volt power supply is enough to get it to the max voltage, but from what I can see from my Google search, I only need to look at the current of the power supply that will be used, the input current, and just meet the input voltage requirements, which is between 6 to 30 volts. Basically, what I understood is I can get away with a bit low voltage, but very high current power supply, let's say 9 volts at 10 amps, since the voltage will be boosted and current will depend on the input and the max current of the converter. If that is wrong, then that's why I'm here. I want to verify and ask what would be the appropriate power supply for such module. I might make it 2 to make a negative voltage for op amps, but maybe I'll just make a dual rail linear power supply for that purpose. All right. So this is a question that closely resembles the kinds of questions I had when I was getting started as well. So you bought yourself a module instead of a, altogether built-in power supply. So it has no AC to DC switching. It only does essentially the DC end of the power supply, and you need to feed it with something. Now, I think a lot of the ideas between these power supplies was to just power it from a battery. And be careful if you're buying one of these, because most of them are only buck converters, like the read-in power supplies I was talking about earlier, the RD6024 and the 6018 that I use all the time. Those are only buck power supplies. They need a higher input voltage than the maximum output voltage you're going to be using. However, this module that this person linked, the ZK4KX, is a buck boost power supply. Not a bad power supply to start in electronics. So something I will caution them is that if they haven't bought this module yet, if they have not purchased it, I would recommend something like a D3806 buck boost module, because you probably want something that can current limit. That's a big deal when you're testing things. If you don't know if a fan is shorted, then you're going to give it its whatever rated input voltage, but you're also going to limit the current at approximately the current that it's supposed to draw, so that if it's shorted, then it'll just go into or overcurrent protection or just regulate down the voltage to keep the current the same. That being said, if you have an ATX, a computer power supply, kicking around, and you want to use a buck boost type converter for your bench power supply, much like Julian Eilert has been doing for years and years and years, then an ATX power supply is kind of the ideal thing to use. These power supplies, they're robust, they are well documented, they have a lot of current available on the 12-volt rail. I would recommend to just go with that. In fact, if you are looking for a nice, reliable bench power supply or something to run 12-volt LED strips with or something, and you see one of these old ATX power supplies, pretty much any ATX power supply will do the job. Either on the curb, on garbage day, if you see a computer tower there, pick that up, bring that home. Or if you see them on Facebook Marketplace or Craigslist for a couple bucks, they are phenomenal power supplies. And yes, the poster is correct. When you have a buck boost converter, there is a maximum sort of input current that it'll allow to pull. And as long as you stay within that input current, then you can actually boost up the voltage to its max and it won't be a problem. So yes, indeed, I would definitely use the ATX power supply. Just make sure to Google which pin of that power supply you'll have to install a switch on in order to activate the power supply once it's plugged into the wall. Generally, when you have it into a computer, your power switch goes to your motherboard, and your motherboard will short a single pin. I mean, I think it's pin 13, but I don't quite remember. Google it. It's everywhere. And it'll short it to ground, and that'll turn on the power supply. So you need to connect, I believe it's the green wire. But anyways, just look it up. A switch between the green wire and any black wire, any ground wire on the big 24-pin connector. And you'll be able to turn on your computer power supply, which you should then use the yellow and black wires off the power supply for your 12-volt supply to your buck boost converter. And then you're going to make up some leads from your buck boost converter to your device under test. Happy electronicsing. Moving on, next post, and probably last Reddit post, because my voice is getting very bad. I have to retake things multiple times. So next Reddit post is by some random guy, 1234737. Need help with a DIY radio kit from 8th Innovation. So they post a picture. It looks like there's a cardboard box. In that cardboard box is a speaker. Underneath that speaker looks like a breadboard, a whole bunch of wires, 9-volt battery, a couple of capacitors, and looks like a module, a couple of resistors. They have a wiring diagram that they've shared, and two wiring diagrams, one with the board and one with the actual schematic. The comment is that it does work, but is extremely quiet, only gets louder, but not much louder, when I rest a finger on a resistor. I'm completely new to all of this. All right. So it looks like Dave Jones's wish for this person actually came true. So Dave Jones always says, I hope you build a kit, and I hope it doesn't work, because that is how you learn the most. So first and foremost, if you are building a kit and it doesn't work the way that you intended it to, first things first, on a breadboard, double check everything. Literally go to every connection and make sure every connection is in the right spot. That's the number one. Not all of the holes are that obvious. Not all of the legs are bent in a way that it looks obvious where it should go, where it did go. Double check everything. So that's number one, all your connections. Number two, double check the orientation of your IC. I can see here that the person or this kit, they have a IC, which is, actually I can't zoom in because Reddit is trash. If I go open image in new tab, does that work? No, Reddit is trash. I can't zoom in, but I can tell that they have a 8-pin dip chip, but I can't tell from their image in what orientation they put it in. So I would say check the orientation of your dip chip. On the very top of a dip package, there is sort of like a recess, and that recess will signal where pin 1 is to the left. I think it's to the left. It's been a while. But make sure that the chip is placed in the correct orientation. Now, from their image, I can see that they want the chip, they place the chip 3 rows from the bottom. So, 4 rows from the bottom. And if I'm looking at the paper diagram, that does look correct, but I cannot tell the orientation, so they really need to double check their orientation. Other than that, I would move the wires up and down in the breadboard to make sure that they make a good connection. Breadboards famously have very bad and dicky connections. They're just little spring tabs. They are a mass market item. You get them, for very inexpensive. They are made very quickly, very cheaply. And so I would say double check that as well, because it's possible that one of your wires isn't making a good connection. Aside from that, follow your wiring diagram and check your voltages. Make sure that your battery is good. If the battery goes low voltage, it's not going to be very loud. And just make sure that everything connected to the positive. They have a regular schematic. Go over, check, make sure everything is on the positive, is getting full 9 volts. Because again, a weak connection will draw down, you'll get lower voltage past the weak connection. So as soon as it pulls current, it's going to have a voltage drop at the crappy connection, and it's going to be problematic. Also, do the same thing. Check the resistance on all your ground sides. So go on the ground side of the 9-volt battery and do continuity checks with all of the stuff on the ground. So the ground even has the antenna on it, so make sure you check that loop as well. Other than that, you just have to start there and work your way. If nothing is working for you, then maybe you have faulty components, so you can start replacing components one at a time. The biggest thing here is to not get discouraged. You have a great learning opportunity in front of you to just slowly and methodically make sure that everything is well connected, everything makes good connection, and your voltages are good. And, take your time. Anything that can be built can be broken. Anything that can be broken can be fixed. So this is a great way to learn. Good luck. I will put a link in the description for all of the Reddit posts that I have answered and helped out on this podcast. You can go and join the conversation if you want to add some more stuff to the conversation. But I think it's really important that every once in a while, if you do have some ability in the electronics world, that you head over to, forums, the subreddit, discords or something like that, and help a couple people. I understand how it is to be completely lost when talking about certain concepts and principles. And so I really appreciate people who took the time and taught me how to do things correctly. And if it wasn't directly, it was through YouTube videos. So, we are all at that point at some point in our lives. So, let's help the people who want to get past that point. All right, this will have to be it for today. I apologize for the shorter podcast, but my voice is leaving my body as we speak. On top of that, it is tax season and tire season. So I am, my body is completely taxed and my brain is completely tired. And so I hope I'll catch you on the next live stream, which will not be this weekend. It'll be at some time midweek next week. Make sure you subscribe to the live stream channel. SE made a stream, so youtube.com/ at SE Streams and get the notifications up because I will post them ahead of time. So you can come join me on stream. And we're going to continue working on the F1 starting lights. Hopefully we're going to get the PCB finished and we're going to work on the code while we wait for the PCBs to be ordered from China. Thanks for listening, everyone. I appreciate you all. And thank you for listening enough to get me on the top 15 electronics podcast list. Thanks for listening.